Hi, I'm Emily,
I'm Kimberly.
and we're from the Need Project, and we are going to share with you an activity today called Lava First Sight. And this activity is going to explore the mixtures of oil and water and why they mix, why they don't mix, and what happens when we add carbon dioxide to that mixture. And that's going to power our lava lamp. This activity is originally created by some of our friends at the Shell Summer Internship Program, and we're happy to share it with you today.
Okay, so materials needed. We have our mason jar. We're using a 16-ounce mason jar. You'll need 4 ounces of water. We've got a packet of effervescent tablets, aka Alka-Seltzer Works, 12 ounces of vegetable oil, and food coloring. Glitter is optional. We're just sticking with our blue food coloring today. Right, so first,
before we do anything, a few notes of safety. We are working with food-like items today, but we're not going to eat any of this science experiment. Sometimes it's fun to eat the things that we're working with in the kitchen, but not today. We don't want to eat any of our science experiments. And also, we want to make sure we wash our hands really well before and after this activity. So, to start, very simple, we're going to take our mason jar. Kim, she's going to grab our oil, and we're going to fill about 2/3 of our mason jar, or about, we'll say, 12 ounces of vegetable oil. So this is a 16-ounce container. She's going to pour it up about 2/3 full.
tell me when.
That should be good. Awesome. Okay. Then, now that we've got our oil, what's next?
All right, next we're gonna fill the rest of the remainder with water. Emily, what's happening?
Well, immediately I'm able to tell that there's a lot of bubbles here coming around the bottom of our jar, and our water sunk to the bottom and our oil is now on top. That's something we're going to talk about as we go further. Our next step is that we're going to add a few drops of food coloring. I'd say like 8 drops, like a bunch. Let's do a lot. And as Kim drops that in the jar, what you can automatically see is that the food coloring is sinking to the bottom, just like the water did. And it stays in its little droplets. It's not mixing with the oil. It's kind of in its little drop form. So whatever shape it came out of the container in, it's going to stay the same. You can add more food coloring than that. You could add several different colors if you wanted to. That's enough to start. And then next step, this is the fun step, is we are gonna break up, we have our Alka-Seltzer tablets, and we are gonna break up our Alka-Seltzer tablets into little pieces. So Kim and I are each gonna do this. And we're gonna break them up into small pieces, but we're only gonna put small pieces in at a time so that we can kind of watch this happen. Okay, so Kim's gonna go first, and she's gonna add a piece, little pieces at a time. And what we're starting to see is the Alka-Seltzer is effervescing, and it's starting to move towards the top. And we're starting to see the food coloring spread out, and we're seeing those bubbles go up and down. So I'm gonna bring it up closer to the camera here. You can see those bubbles starting to rise to the top and fall back down. Kim, let's go. Let's do more. What do you say? And the more she adds, the more vibrant and the more active our lava lamp is going to be. Wow, that's fizzing. I'm gonna add a little bit more at a time here. And we can see that our bubbles are rising and sinking as we add more Alka-Seltzer.
This side's cool.
The only thing you want to be careful of is if you add too much Alka-Seltzer too quickly, you could have a little bit of an overflow situation as we're starting to see our fizz come to the top and hang out there a little bit. So what's happening here? In our jar, what we've got is oil and water. And oil and water don't mix. You may have heard that before. Just like water rolls off a duck's back, oil and water, salad dressing, they separate. Why is that? It has something to do with a property we call polarity. And polarity describes the shape of the tiny little molecules of oil and water. And oil and water are opposites. Water is polar. So we call water a polar molecule. The molecule shape kind of looks like Mickey Mouse. It's got two molecules on top and one molecule in the center. Oil is not polar, and those opposites are like attracts like. And so when you mix two polar materials together, they will combine evenly and you won't be able to see them. When you have two non-polar substances and you mix them together, again, they'll mix very well. When you have one of each kind, they will do just what our oil and our water and our food coloring did. They'll separate out. The reason that our oil goes to the top and the water moves to the bottom is because of another property we call density. Our water is more dense than the oil, and it has more mass per volume, so it's going to sink to the bottom and the oil is going to float on top. How does the food coloring fit in? Well, the food coloring is just like the water. So it is going to be a polar molecule, and therefore it's not going to mix with the oil, and it's going to hang out in its little bubble shapes with the water until we add that carbon dioxide. The carbon dioxide bubbles came from the Alka-Seltzer, from our tablets, and what happens is that Alka-Seltzer reacts with water, and it forms a chemical reaction that lets off bubbles of carbon dioxide. As the carbon dioxide mixes with the water, it's going to rise to the top because it is even less dense than the oil. And so it's going to move its way to the top, and as it does, it's going to bring a few blue molecules along for the ride. And so it brings that food coloring up to the top. That food coloring remembers its density as the carbon dioxide bubbles pop, and it sinks right back down to the bottom again, keeping our colors moving like a lava lamp. And as you can see, our bubbles have sort of slowed down, and that's slowed down because most of our Alka-Seltzer is gone. So as long as our Alka-Seltzer is reacting and bubbling and fizzing, our bubbles are going to keep rising to the top. And as those bubbles die down, we'll see that most of our blue bubbles will sink back down to the bottom. That's our lava lamp. Hope you found it to be lava first sight.